Alright, hey class, so today I'm just going to do a quick review on Lewis structures. Now, all the Lewis structure is talking about is just where are the elements placed relative to each other. It's just essentially their structure, okay? If you have something like H2O, how would they orient themselves compared to each other, and where would their electrons go? So, now, I know this seems like a lot of rules, but if you go through it step by step, it kind of makes sense. So the first thing that you need to do is to count out how many valence electrons you're starting with, okay? I can't stress this enough. There's no way that you can draw this without knowing how many electrons you have to play with, okay? So make sure that before you even start drawing anything out, that you know how many valence electrons. Now remember, you can figure that out by looking at your periodic table. Okay? For each column, or for each group, that's another valence electron added. So for the first two, that's one valence electron, two valence electrons, and then you move over to where like boron and aluminum are. That's 3, and then you go 4, 5, all the way until you get to 7 valence electrons, okay? Now that's like how many sodas you're bringing to a party. Now imagine that you want to play different games with sodas and whatnot. Well, you need to know, well, how many do I have? Because that's going to limit how many games I can actually play. Well, if you don't know how many electrons you have no hope of being able to figure out how to distribute them amongst the different elements, okay? So that's step 1. Step 2 is by putting, when you're drawing out your actual structure, since that's what the goal is the least electronegative goes into the center. If it's carbon, then it's carbon. If not, then you'll see. It's pretty easy to tell which one it is. Usually it's the one who's alone. Alright? The second part is to draw on the bonds, because you have to see who actually connects with who. The next step is to actually distribute the electrons. Now remember, you only have what you're given. You can't magically just draw in 2 extra electrons if you don't have them. You can only work with what you have. So make sure that at the end you count them up, and the number that you started with is the number that's on your Lewis structure. The 5th step is that make sure all electrons have 8. Now remember, if you go to a party and you bring 6 cans of Coke, are you going to follow those 6 cans of Coke? No, you're going to just put them into the pool, whoever brought Coke, and then you're going to grab what you need to play your game. Alright? So let's say that in order to play your game, you need 8 cans of Coke. Sure, you can grab your 6, but you need 2 more. So you're going to grab 2 more. It's the same thing. Just because someone starts out with 4 doesn't mean that they're only going to get 4 in my Lewis structure. They need 8. Okay? And then the last step, that's more like if you ran out of all of your electrons, you still need, some of them still don't have 8, then that's when you bring double bonds into consideration. Okay? But let's go ahead. I get that this is a lot of rules, so let's go ahead and just try one and see how it goes. Okay? So today what we're going to be doing is 2 different molecules. Now, if you want and you feel comfortable doing Lewis structures, go ahead and do it right now, and then double check and see what your answers are by fast forwarding it and see what I got. Okay? If it's what I got, then you are good. If it's not, then alright, try again and we'll see what your mistake was. Alright, so like I said, step number one is writing out how many valence electrons, okay? So I have 1 phosphorus and 3 chlorines. Can you tell me how many valence electrons is phosphorus? Very good. 5. So he's bringing 5 cans of Coke to the party. What about chlorine? Very good. 7. However, it's kind of like saying that I'm bringing 3 brothers are coming to the party, each of them bringing 7 cans of Coke, okay? So it's not just 7, but it's 3 times 7, all right? So that's 21 plus 5, which gives us 26 electrons that we have to work with, okay? These 26 electrons need to be distributed throughout all of my molecules. So like I said, the least electronegative, which is, very good, phosphorus, he's going to be my center atom. So I'm going to go ahead and erase this part so that way I have more room. But keep in mind that I still need to remember I only have 26. So at the end, I should only have 26 electrons in my structure. Alright? So let's start with P. Well, we know that he's going to bond to the 3 chlorines, right? So we need to take that into consideration. We have 1 chlorine, 2 chlorine, 3 chlorine. Okay? Now, with each bond that I created, I already used two electrons. So based off of my bonds, how many electrons have I already used just by creating those bonds? Very good. I used up 6. Remember, 2 from him, 2 from him, and 2 from him. Okay? So I used up 6, which means how many electrons do I now have? Very good. I have 20. Alright? And so what was my next step? Alright, my next step was start from the outside and work my way in. Now, each one is going to want 8. That makes them happy. If we had a hydrogen, then okay, it only wanted 2. But do you see any hydrogen? Nope. So let's go ahead and distribute my electrons, okay? So we're going to look at this chlorine right here first. Now, it already has 2. So how many is it going to want now? Very good. 6. So I'm going to draw in 6 electrons. Okay? So I draw in 6, which means how many do I have left? Very good. 14. So let's move on to the next one, okay? Noticing that this guy right here, this chlorine, already has 2 in play. How many does he want to make 8? Very good. 6. Okay? Which means how many do I have left? 8. And then same thing for this chlorine, so I added another 6. Now do you see I subtracted 6, which means that I have 2 electrons left, okay? Now chlorine's happy, all 3 of them are happy, so who am I going to add it to? Very good, I'm going to add it to the phosphorus, okay? Because the phosphorus, how many electrons does he have? Very good, he only has 6. Alright, he has it from this 2 from this bond, 2 from this bond, and 2 from that bond. Okay, so he only has 6. So we put him the 2 lone pairs in order for him to have 8 electrons. Okay, so that's all that it is for Lewis structures. Alright, well let's go ahead and try another one that's a little bit more tricky. Alright. But in essence, this is what your structure should look like. So if you were able to get this on your own, awesome. You're going to do just fine on my test, okay? So let's go ahead and look at this other molecule. Now go ahead if you want, try doing it on your own. We've done it before in class, but I wanted to make sure that everyone was able to understand what was going on for this, okay? So what's step number 1, guys? Very good. Count out the valence electrons, okay? So what molecule or what elements do I have? I have 1 sulfur and 2 oxygens. Sulfur has how many valence electrons? Very good. 6. How many does oxygen have? Good, 6. However, how many oxygens do I have? 2. So that means that I have 18 electrons to play with. Okay? Means 18 have to be distributed between my S and my 2 O's. Now, sulfur is going to be my central atom. So least electronegative, it's all by its lonesome, okay? What's the next thing that we have to do? Very good. We have to draw out the bonds for each of my oxygen, okay? So how many electrons have I used now? Okay, 14. Very good. So I have 14 left. So who am I going to start with when I'm distributing my electrons? Am I going to start with the sulfurs or with the oxygens? Very good. I'm going to start with the oxygens. So how many do I need around this oxygen in order to make it 8? Very good. So go ahead and draw it in. You're going to need 1, 2, 3, 4, 5, and 6. So how many do I have left over? Very good. 8. 1, 2, 3, 4, 5, 6. Now you notice I didn't even touch sulfur. I have not touched sulfur yet. So make sure that when you're doing this, you start from the outside. Don't worry about sulfur until the very, very end. Now I used up 6 more, so I have 2 left. So who are these 2 electrons going to go on to? Very good. You're going to go on to sulfur. Now, are we done? Can I call it a day, box my answer, move on? No. Because look at sulfur. What's going on with him? How many electrons does he have? Very good. He only has 6. 2 from each bond. And then 2 from the lone pair. Okay? Now those 2, which means how many does he need in order to be happy? Very good. He needs 2 more. So what he's going to do is he's going to go over to his friend, oxygen. You can pick either one. That one doesn't matter. He's going to go over to his friend, oxygen, and he's going to be like, dude, share some of your bologna sandwich. Share some of your electrons. And you know what oxygen's going to say? Okay. So what happens is that he's going to take away, he's going to give away 2 of his electrons. But remember, oxygen still wants 8. So he's not giving them away per se, but he's saying, all right, I will share. And that's where the double bond is formed. Okay? Now let's say, for example, that this lone pair didn't exist. We didn't have those extra 2, and we still wanted to. Well, because sulfur still needs 8, instead of asking again from him, he's actually going to go like, hey, yo, bro, this oxygen already gave me a couple. Do you mind sharing? And he's going to say, why, yes. And so he will, and he'll create a double bond. However, because we have those 2 electrons, let me go ahead and back that up. Because we already have those 2 electrons, there's no need. And this is my structure. Okay? So if you're able to do these, then I'm pretty sure you will do just fine on any Lewis structure that I throw at you. Okay? Just remember to keep those the same. Also remember that electron pairs are always in pairs. You never separate them. I should not see this. This is bad. Okay? That is not correct. They never are separated. And they're cliques, so they like to stick together. Okay? So even if I have more than 1 electron pair, they will always be found on the same side. They will never be separated. Okay? They're cliques. And I think that's it. If you want any more practice problems, just hit me up, email me or something, and I'll try to see if I can send you a couple more molecules, okay? All right.